Hello again and welcome back to the Jeepster build. I started putting together a video on some of the wiring I'm doing on the Jeepster. And as I'm doing it, I'm thinking, I've got a lot of years of knowledge on doing this kind of stuff. So I'm just kind of skipping over so much that I'm just not doing it justice. If I'm not going to get into all the detail of all the wiring and the wiring kit, why bother? Because it's not entertaining. I want it to be informative. So I'm kind of going to be skipping around a little bit. I'm going to be doing some video as it makes more sense, and then I'll kind of jump to what I've actually done and how I did it. So what I've got is, since there's hardly anything original when it comes to the Jeepster, maybe the headlights and taillights, dimmer switch, so I bought a whole new wiring harness for a hot rod, and it is a Speedway Products wiring harness. It's a 12 circuit kit. And what a 12 circuit kit is the circuits that would be required just basically for bare minimum of something like this, like you would do a hot rod, a roadster, or maybe a two-door, where you don't have power windows, you don't have air conditioning. There's just very limited amounts of items that you can run off of 12 circuits. The only thing that this won't do for me is the air conditioning. Well, I'm not planning on doing heating and air conditioning in this right away. It's a down the road, kick it down the road idea. So I'm leaving everything where it'll be easy to add, but I'm not putting it in yet. So that circuit won't be on this fuse box, but there's nothing wrong with adding a little supplement to this just for the AC. And like I say, I don't need cruise control and power windows and all those other options. So a 12 circuit kit is perfect for this kind of a project. This particular kit that Speedway put together, it's pretty inexpensive. 150 bucks I think is what I ended up paying for this. It was on sale. I've seen them as high as $200, $230. So it's a pretty good buy. Be careful on what kits you buy. There are a lot of kits you can buy that are at overseas makes or kind of backyard makes that aren't a good quality. When I talk about quality, I talk about gauge of wires. That's where people get in trouble most with wiring. They don't understand what amperages and the amount of flow and what things need to run through all the wires. And if your gauge of wire is too small, then you're not providing enough power and you're overloading those wires, and that's when hot rods start to catch on fire. When working in the hot rod shop, sadly I saw a couple of hot rods that had some fire damage because of wiring. And I personally experienced it in a Dodge Dart that I was driving, and the dash went up into smoke, and it was inadequate fuses. And I hate to even touch on it, but I will definitely go into detail about it, and that's a fusible link. So there's a lot of information that I've learned over the years, and I want to be able to share it in good detail, as well as connectors. These connectors are okay, but I have seen a lot of failures with these connectors because people don't have the correct crimping tools to get them on solidly. So I don't even use them. I hate them. I don't like the looks of them, and I don't like the failure rate. I solder all of my parts on, and I should say all. There are some exceptions, and I'll show you those too. There are some really, really awesome crimping tools where you can do it right. So along with this kit comes fantastic instructions. And the low-cost kits, instructions are not very good. Even as good as this kit is, it is really difficult to follow. There's a lot of things about this kit that left me scratching my head. I got to the point where I had to put in the fuse box and wire up a battery so I could start literally physically testing each wire to make sure it was doing what I wanted it to do and what the kit says it would do. Because let's face it, a lot of these wires, even though they're labeled, you don't know if they're positive or negative. And many of these wires are negative. But to simplify it, I guess whoever designed this and put it together thought, okay, well, if it's a front signal, it's power. If it's a gauge, a lot of the gauges are negative, they're ground. Well, unless you have a whole lot of knowledge about wiring and the gauges and different switches, you're not going to know that. So then you end up doing a whole lot of testing. And just to be safe, that's what I ended up doing. And I'll walk you through all that and I'll show you what I ended up doing. So, I did a whole lot of notes because I still had a whole lot of questions because I have an electronic distributor. And it's just not a standard distributor. So I needed to find out all the wiring for that. Well, it came with the motor when I bought it. I didn't have a manual. So then I had to find out what it was, who made it, and what their wiring specs were. Make notes. The Phytech carburetor, fuel-injected carburetor, there's 6 wires going to that thing. Some going in, some of them are coming out. So, don't have the manual for that. Had to find it. Make notes. What is all that wiring? What's it for? What does it do? Lots of notes. The light switch. I'm doing a light switch. Long story, but basically my dash is a 1950 to 1955 Ford. I stopped Willys. So I got to pull up the Ford specs so that I know how to wire the key switch and the light switch and the switch for the wipers. So I got notes for those. The steering column, I'm using a GM steering column. Need to know the wiring for that. Luckily this came with the steering column. Alternator, I'm going with a GM style 1-wire alternator. There's some notes in the kit that talks about it, but it is not very descriptive and very difficult to understand. So as I'm deciphering all this stuff and I'm doing so much research online, I'm making notes on all of these instructions. So I'll walk you through some of those, and we'll talk about the alternator. And basically there's 3 different types. There's an alternator with a built-in regulator. There's an alternator with a partial regulator, and there's an alternator with nothing, and you would have an alternator set up somewhere else within the car. If you're doing a 66 Mustang and you already have your regulator, your standard alternator, simple wiring. This is not simple. And the gauge of wire, depending on the amps of that alternator, is critical. This is a 100 amp alternator. Why did I go to 100 amps? Typically when you do 100 amps, it's if you're drawing a lot of power for a lot of things, air conditioning, power windows. Well, I don't have all of that, but I want to plan ahead for the air conditioner because I want to be able to have a good, clean power because I have a computer in this carburetor. So I want clean, good power. So I went with a higher amperage. So I've got to go with higher wires. The starter on this. I'm not going with the original Ford starter because it is a high compression engine. So I went with a high compression starter. With a high compression starter, it has its own relay and solenoid to kick in that starter. So I don't need the Ford style relay sitting on the fender that everything connects to and then the starter switch connects to send a signal to the starter. So those are other options. Bypass that. What wiring do you need to bypass that? It's not very specific on all those things. So then I gotta get the wiring for the starter. So all that information, notes after notes after notes. Even down to the dimmer switch. I'll go over that too. Dimmer switch kicked my butt. You'd think something with 4 wires would be simple, but it was very confusing because the instructions, even with everything labeled, a lot of the dimmer switch is feedback. You got a wire that's giving you feedback from the headlights saying that the brights are on. So those are things that the only way I could do it, the only way I could figure it out was to put in the battery and literally start testing those because they just didn't make sense. I did finally figure it out. This kit comes with all the wiring and plugs for the GM steering column. Your signals, your flasher, your brakes, everything runs through that. If you are having a GM column that has the starter in it, it also has all the wiring and connectors already set up for that. And that's a lot of what this is. Neutral safety switch, if you've got a shifter. So that wiring, I cut it all off because my column has lights, flasher, brakes, but not all the rest of the stuff that you would have on one with the starter or cruise control for that matter. So then I've got to come up with the wiring for a different starter. Well, this starter key switch just happens to be the one I'm using, the Ford. So luckily that was there, but it was easy to figure out anyways. All the gauges. If you're going to use all these gauges, the wiring is there. It's all provided. And then there's a couple of diagrams for lights. None of them pertain to what I'm doing, so that's why I had to come up with my own. And then this piece is the plug for that steering column and how that's wired. Luckily, the wiring on this was an exact match to the steering column, so that made that simple. As you can tell, just how long it's taken me to describe all these instructions, this isn't going to be just a simple, I'll do it in 20-minute type of a video. To give it any justice and to be able to give any knowledge to people that may be interested in this, I'll probably end up doing this in 2 or 3 parts to really get into some detail. If you're wanting to build a hot rod, these are the things you're going to have to learn to do, or you're going to have to pay somebody a lot of money. And I mean, I've got a lot of hours into this one. The amount of hours in wiring really surprised me, because I've done a lot of wiring over the years, but it's usually in bits and pieces. I've never completely wired a whole car. And between the research and the physical hands-on, I'm at 3-4 days into this, and I'm not done yet. So I'll try to skip through it as best I can, and hopefully you can learn from it. When it comes to going from a vacuum windshield wiper to power, fuel injection, it really gets overwhelming. But if you just concentrate on separating out what you need just a little by little, I need a few wires that go to the carburetor. I need a couple of wires that go to the distributor. I need a couple of wires that go to the starter. And this group all goes to the carburetor itself. But some of these wires share wires with other things on this engine. So that's what I'm going to do. I'm I'm going to separate this bundle. I have a bundle of wires here that go to the front end of the car. It definitely gets overwhelming, but if I separate turn signals, park lights, headlights, horn, those kinds of things, I can set them aside and it makes it a little less overwhelming. And then I can just start pulling, okay, I need a tack wire, I need a coil wire, and I need coolant wire, I need fan wires, I need a wire that goes to my oil pressure sending switch. If I just start pulling those strands, keeping the fuse box, the new fuse box mounted somewhere behind the dash, and then I can drill a hole in a spot that's going to feed the motor, and then I can drill a hole in a spot that's going to feed the lights, and then the starter, and so on. Alternator. So just try to get a few things at a time and not be so overwhelmed. So what I want to concentrate on first is I want to separate all the wires for lights, get them out of the way. I don't need those. And we'll just kind of go from there. So each one of these wires is labeled. So this says oil sending unit. So I want that on the side. Temperature sending unit. And just keep setting those aside. And then lights, setting those aside. I thought this was going to be difficult to find a place to mount the fuse box. And it just so happens that the dash is right here, and it's just straight back. It's just perfect place to mount it. Still be able to see it. Take the cover off, and there's the fuses. Now that's perfect for the dash. Cover comes off. Now these wires, I'm going to have to run up into this area. And I need access to this bundle. This goes to the battery and the starter. The rest of these go to the tail lights. So these that I have all separated out, these go to the engine. This goes all to the headlights up front, the horns. So that one I can leave side here out of the way. These all go to the dash and the steering column. And these also go to the dash and the key switch. So all of these wires will be on top of that. Alright, clear as mud. Now in following the instructions for this kit, there are 3 options for alternators. The most common, follow the instructions, it's pretty simple. If you're doing what I'm doing and you're switching to a 1-wire alternator that is higher amperage like this one, if it's over 80 amps, you need to upgrade the wire to that alternator. If you follow the instructions on this, the standard alternator wire that comes in the kit, you could connect directly to that if it's under 80 amps. But being over 80 amps, you don't want to do that because you will overload this wire and you'll overload the system. So this wire then it will be connected, in my case, there's going to be different scenarios. You can connect this to a terminal block or a transfer block of some sort, like the type of solenoid that comes on a Ford, or you could connect it with the battery terminal on the starter, and that's what I'm going to do. So by connecting it there, then you're only running the load that the rest of the kit the rest of the wiring is asking for. You're not sending more than it can handle. And that's why it's a smaller gauge wire. But then you've got to connect the alternator to the starter or directly to the battery. I like to go to the starter because it's so close and you end up with a shorter piece of wire. They provide this in the kit, and it is a jumper wire, they're calling it, for the alternator, but I don't know what gauge this is, and I don't think it's heavy enough gauge, especially for 100 amps. 100 amp alternator, I think it needs to be a heavier gauge. So I made this little jumper wire, which is a 10 gauge, and then I will hook that directly to the starter, and then when it comes to charging the battery, then the power going back to the battery will be in this main cable. And then this alternator needs to be grounded. So I'll do the same thing. I'll cut a piece of 10 gauge black ground wire, and I'll ground that directly to the block. And that brings up a good point. Ground, ground, ground. It's one of the things I see people get in trouble when they're doing a lot of custom stuff, is they're not providing themselves with enough grounding. You want to have a good heavy gauge ground to the body and a good heavy gauge ground to the engine. This starter wire that I'm using is a 2 gauge. Most situations when you're running starter wire, you can run a 4 gauge. This is a 4 gauge welding wire that I have. V6, 4-cylinder, small V8, you'd be fine with a 4 gauge. So I'm going to go up to the 2 gauge. Now I've got all these pieces here cut to length, but I want to have a nice loom around it to make it look good as well as kind of hide it. So I will make sure all of this now fits together, and then I will wrap them and get everything mounted. So this is the wire loom I like to use. It's split so that you can run the wires down through it, and then it's spring loaded and it just really grips. Something that I ran into years ago at the hot rod shop. I just really enjoy using it. They do have a tendency to fray a little at the end. You can just use a little fire on it or a little heat gun or something to kind of melt that together, and then I just wrap the ends with black tape. But you can see, putting the piece on, it's a little awkward to open it up because it's pretty springy. It holds really, really well. I've got 2 different sizes I use. This is a 1/4 inch, which works great for a couple wires. When I'm using a pretty good bundle, I've got, I think, a dozen wires going through one that's a 1/2 inch. And that's what I use for my wire looms on the other side, and I'll show you those too as we move along. But it is a little time consuming to get them on. And just wrap it good with electrical tape. And I'll wrap this other end, and then you've just got a really nice professional looking finish. Okay, now with my alternator hooked up to the starter alternator wire that goes back to the fuse box, those are hooked up. Then the only thing that's really left is this main cable. It's called a solenoid wire, and it probably went to the solenoid on the firewall or the inner fender well. This will then be changed over directly to the battery. And following the instructions, this requires a fusible link if used this way. And a lot of it is because of the higher amp alternator. What the fusible link is it's like a fuse, but it's different. but essentially it is acting as a fuse. If I had a cable that was this big and I had a good idea on what the amperage is that's going to be going through this and all the amperage that's going to be used in my fuse box, I'd probably want to add an inline fuse. I did it on my show car. I was running a lot of amps, power windows, air conditioning, everything through that. So I put a 100 amp fuse on my firewall and connected that to my battery, and I ran all my power through that. 100 amp is pretty uncommon, but I had some heavy wires. Something like this is probably more of a 30 amp, maybe even an 80 amp, like the alternator is. So in the circumstances of this gauge of a wire, the kit planned on this particular piece, so they included it in the kit as an option if you're doing heavier loads like I am. So by putting in this fusible link, it acts like a fuse. This wire just burns up. You could put in a fuse, but according to the specs, you'll void your warranty if you don't use this. So go ahead and use it. It already has the connectors on it. They're not the kind of connectors I really like, but I spliced in so that this piece is removable. So if this fries, pop it out, pop in a new one. And then this wire is going directly to the key switch. And everything that you do on that key switch, whether it be accessories, whether it's on for the engine, or whether it's hitting that start button to start this up, it all runs through this heavier gauge wire. And that's why this is so critical. And then everything else is running, like your radio and things like that, off of different switches on that key. So another key piece, this will be directly on the battery. You could hook this to the starter. I know my Buick was hooked to the starter, but it doesn't give you easy access to this if you end up blowing it, to be able to just pop it out and replace it. So it's not as clean having it on the battery, but it is a critical piece, so I want access to it. I'll do a close-up here and I'll show you what I've done and how critical these wires are. And these 3 wires are very critical to not burn the car down. So with the close-up now, you can see my wire loom that goes from my alternator. I've got my power and my ground. It goes then to the back side of the starter, and the starter then I have my starter cable, which goes to the battery. I've got my wire loom, which now is my what would have been my alternator wire, but that's the wire that goes to the dash or the key switch. And then I have wires that go down to my oxygen sensor and my main ground. You always want a very good heavy ground. Whatever wire you use for the starter, for the power, you want to use the same gauge for your ground. These are both 2 gauge, and then my fusible link that runs up here. You'll see I've got a group of wires here that are running basically alternator, key switch, starter switch. These are running all of your real high-end amperages, and you want to make sure you've got good grommets and you've got everything wrapped well, so there's no way this can get cut through and grounded out, because those are the ones that start fires.